of the registrar. Sorry, I'm just gonna yeah, okay, thank you. Uh, okay, I'll continue. So now that we have this extruded, we're just gonna fillet the corner. We're gonna fillet it 2 millimeters. So just like that. And now we should have this shape. It's basically just like a dome. So now that we have this, we want to actually toggle the visibility of the XY plane. So to do this, in our model tree on the left-hand side, we're going to click the drop down on the origin, and then we're going to select the XY plane. We're actually going to right-click it, and then there's a button that says visibility. We're just going to click on that, and what that's going to do is it's going to bring up this center plane that we have over here. And from this, we are going to want to make 3 offset planes from this plane. Basically, what this is doing is it's defining the planes that the propeller blades are going to loft through. So if I go up to the top, there's a tool that's called the plane tool, the work plane tool. It's like this orange square with this white square in it. We're not going to click on the tool, but we're going to click on the drop down, and we're going to select offset from plane.
Hey
So now
Jordan,
that mhm.
sorry to interrupt, but if you have a version of the part you're gonna make like saved somewhere,
Oh
would you
yeah,
mind like
true.
opening it up just to show what we're trying to make today?
Yeah, okay,
Yeah.
sorry, I should have mentioned that. So basically what we're making is we're making this propeller blade. And if you attended some of our other workshops, you may recall we actually had a drone body with a drone assembly. So I have this open here too. Oh no. Okay, inventor. So we made this a while ago. Basically what we're doing is we're making a more advanced version of this propeller that can fit on top of this motor housing the same way that that this one that was provided to you will. So it has the same like inner and outer dimensions as this one, but it's just got a little bit of a more complicated shape to it, just so we could show off some inventor tools, mainly focused on making more advanced lofts in this workshop. So this is the final product that we're going to be working towards, just so you guys can have an idea of where we're going. So actually, thank you for mentioning that. I'll keep that open. So what we're going to do next, now I'm back to the part, is like I said, we're going to offset from this XY plane. So we're going to make 3 offset planes. So one is going to be 3 millimeters out. Here, I'll actually just turn this around. And if you didn't know, first of all, you should always use Inventor with like a mouse, by the way, not a trackpad. I know some people did that in first year. It's so much better with a mouse. You can shift middle mouse to like rotate around the center point. So I made this first plane 3 millimeters offset from the origin XY plane. Again, from the origin XY plane, I'm going to offset another plane, and this plane is going to be 33 millimeters out. And then I'm going to do that one more time. Again, all 3 of these are coming from the center XY plane, and this plane is going to be 100 millimeters out. Oh, there we go. So 3 planes that look just like this. And this is basically what you should have. So what these 3 planes are, they're going to be the surfaces basically that we're lofting through. So if I go back to the final product, you can see there it's kind of angled downwards here, and angled downwards here. So we're going to make 3 sketches that for this loft to follow along. So the first plane that we're going to start with is we're going to start with the 100 millimeter plane. So that is this plane all the way on the end over here. So we're going to start a sketch on this plane, okay? And sometimes like the body might be like rotated. So to change that, you can just like you can use this cube. You can click these arrows on the sides to rotate the view properly. If it doesn't look right, just a quick way to orient it correctly. But we're going to project we're going to use this tool called project geometry at the top when we're in the sketch on the 100 millimeter plane. And what we want to do is we want to project the body of this cylinder. So we're going to make sure that the body is highlighted here. So like this circular ring. And what that's going to give us is it's going to give us the top and the bottom projection of this cylinder. And then what we also want is we want these lines on the side to make a rectangle that has the dimensions of the projection of the rectangle. So in order to get that, you're going to need to kind of like move around on the cylinder. You'll find this line on the left side. If you click on that, you should get a line that appears on the left. If you look on the right side, there should be not this one, because this line is actually the inside of the inner cylinder. But if you go more towards the outside and click on the edge, then you should have this rectangle. And this is what you want. You should have a rectangle that looks like this. And once you have that rectangle, you're done with the project geometry tool for now. So you can just press escape to get out of that. And then once you do that, you want to make a center line down the middle of the part. So I'm just making a line that's going from the top of this to the bottom of this, dividing the projected rectangle that we made into two parts. So now the next thing that we're going to do is we're going to use the 3-point center rectangle. So if you click the drop down in rectangle, you can find it over here. And before we actually make our line on this sketch, I want to change to construction mode. So if you see where my cursor is highlighted, there's a button that says construction. And basically this just makes the lines dotted instead of like solid. And that just makes it easier to see what is actually part of the part and what you're kind of using to line things up. So I just selected that. And now what I'm going to do, again, I'm still in the 3-point center rectangle tool. I'm going to select the middle point. And you can just go up and down along the center line, and then it'll turn green at the middle point. I'm going to click once in the center. I'm going to make a line that is 7 millimeters long. And for degrees, just keep it at 0. And then once I do that, I'm going to make it 1.6 millimeters high. So then I should get a rectangle like this that is dotted, and it'll have these like crosses on it as well. So once I have this rectangle, I'm going to make one more dimension, not with the rectangle tool, but just with the line tool. I'm still inside of the construction line view. So I'm going to click from the top of the rectangle that we just made, not from the center, but from the top of this rectangle. I'm going to go over to the right 1.75 millimeters, 0 degrees, and I'm just going to dimension that over there, just like that. So now I'm going to exit out of the construction line view. So at the top, I'm just going to deselect construction over here, and this is going to make it so we can just make those solid lines again. And the next tool that I'm going to use is going to be the 3-point arc tool. So what this point does is it basically just makes an arc where you can define the endpoints, and you can also define the center point of the arc. So to define this, I'm going to click once on the bottom left-hand corner of the rectangle we just made. I'm going to click once on the top right-hand corner of the 1.75 millimeter line that we just made. And then I'm going to define the radius of the arc to be 15 millimeters. And now you should have a line that looks just like this, with an arc that looks about this shape. And we went from the top right corner of the 1.75 millimeter rectangle to the bottom left-hand corner. And this black line, just ignore it. Inventor just kind of like makes those sometimes to line things up. But now that we have this line, we're going to draw a line along the bottom of this rectangle to make it real. I'm not actually going to draw a line here. What I'm going to do is I'm going to select the line, the construction line at the bottom, and then I'm going to click the construction line tool, which we used earlier, and that basically will toggle it from being a construction line to a normal line. So now you can see that it's solid instead of being a construction line.
Hey, Kieran, just to make it easier to see, there's a button on the bottom of your inventor that looks like a the one to the left of that one.
Oh,
yes, slice graphics. Yeah, if you just enable that. Oh, okay. It looks like
it didn't really do anything.
Okay, never mind. No, never mind. So what that button is supposed to do is like when you're making a sketch on a plane that's sort of inside some geometry. It's like basically gives you like a section view of the geometry. But I forgot you were sketching on a plane that was all the way up there. So
yeah, I think that'll be useful though when I go to the 3 millimeter plane, because the way that I did that was I toggled the visibility, but instead that could be useful.
Yeah, sorry, keep going.
Yeah, no worries. Okay, what I'll do is I'll just angle the view a little bit so it doesn't have all of these planes in the background, so it's a little bit more clear as to what's going on. So, yeah, anyway, where were we? Okay, so we just made this line. So the next thing we want to do is we want to make a fillet that's going to kind of give that aerofoil shape of the wing. So we're going to use the 2D fillet tool. It's up here right next to the rectangle tool. And we are going to make a 1.5 millimeter fillet. And for the 2D fillet, you want to enter the dimension before you actually make your selection. So radius of 1.5, and it's going to be between this line, which we just made, so this arc, 15 millimeter arc, and the most right-hand construction line. So it should highlight green like this. If you click on the 2, it should make this arc that gives this kind of smooth shape. So this part is a little bit annoying because it doesn't actually join up with the edge, and this is something that you're going to have to pay very close attention to. So now we want to close the gap between this line, this arc, and the bottom. So what we're going to do is we're going to zoom in all the way on this corner. You'll see this construction line is dotted. The same way that we did before, we can just turn that into a real line. And this should be joined now. Actually, I'm not sure if I'm not sure if that exactly joined it. I think a better way might just be to make a line that connects from the bottom of that corner to this bottom corner. Your line should be 0.048 millimeters in length. So just double check that your line is that length, because if it's not that length, that means that you probably selected something a little further up. But yeah, okay. So that's how we did that. So now we're basically done with this end sketch. So we can just finish that sketch over there. And just going back to our final part. So what we just made was this very end sketch. You can see this is like very far out from the body. So that is what this sketch, that was what the purpose of this sketch was. So that was to define the endmost plane. So now the next thing that we're going to do is we're going to try and get that body rotation. So if you notice, this kind of has this like bent shape, this bent sort of geometry. And in order to get that, what we're going to do, oh, sorry, wrong sketch. What we're going to do is we're going to make a new sketch on this work plane. But before we do that, I'm actually going to toggle the visibility of our solid body just so that it's a little bit clear what we're doing. But I think one more thing we can do is we can also use that section tool. That section tool also, but I'll just turn the visibility off for now. So I'll make a sketch here on this first work plane. Keep in mind, this is not the plane that divides the solid body in half. It's the one that was offset 3 millimeters from the center. So that's the plane that we're making a sketch on. This one right here, not this one. So once we made this sketch, what we're going to do is we're going to project our geometry all the way down from the sketch that we just made. And these are the geometry pieces that we need. So we need this entire aerofoil shape. So what we're going to do is we're going to click on this curve, the bottom curve, the fillet curve, and we also need to remember to select that tiny little piece. Oh shoot, where is it? Sometimes Inventor is a bit finicky. We also need to select that tiny little piece that we use to, oh, there it is. Oh my God. I had it for a second there. Jeez. I think maybe I should delete that construction line. Oh, of course, now it wants to select. Oh, really? I didn't know that. Okay. So if I just curve. Oh, there we go. Awesome. Thank you. So yeah, just make sure you select the one that's solid and not the one that's dotted. Awesome. Thank you so much. I actually did not know about that. It's an awesome tool. So we have projected those four, and now we just need to project the center line. So those are the 5 lines that we need to project down from our sketch. So the entire curve as well as the center line that divided it in half. So now we can exit out of the project geometry tool, and we're going to focus now. We can forget about this sketch that we made. We're going to focus on this plane over here. So we actually don't want this curve to be associated anymore with the tool that we projected it from, because right now it's kind of bound. Like it has a constraint that says it has to match the projection of this curve. We want to get rid of that. So in order to do that, we're going to highlight all of the selections that we just made. So again, 5 lines you should have. We're going to right click and we're going to click on break link. And it's going to be unconstrained, but that's all right for this workshop. Now we should have basically still an identical projection of this sketch down onto this plane, but it's no longer linked to the geometry of the other sketch. So now that we have this, we want to rotate this 25 degrees counterclockwise around the center point of this aerofoil shape. So how are we going to do that? So what we need to do is we actually need to break this line. And in order to do that, we're going to use the split tool. The split tool is up here. If you go next to the 2D sketch, it's right next to rotate, between rotate and offset. This is where the split tool is. And we're going to want to break it at 2 points. So you see if we highlight, there are kind of these red X's that come about. So we want to click on the center line once. It'll break it once. And then we don't even have to move the cursor. If you have your cursor in the center, you can click on it one more time and it's going to break it a second time. And now what that did is instead of one continuous line, it is now 3 lines that is broken up into 3 sections, and it got split at the intersection points between this line and another curve. So the reason why we did that is because now we can use the point tool, which is right next to the rectangle tool. If you see where the 2D fillet button is under text, the bottom one right there, point tool. And we can make a point that is right in the center of this new line. And we couldn't have done that before, because if we tried to make a point, it wouldn't have locked on to the center of this line. It would have locked on to the center of this long line, which is not the same as the center of this small line. So basically the whole reason we did that was to get this point here in the center. So now that we have this, we're going to make our 25-degree rotation around this center point. So we're going to do that by clicking on the rotate tool. And the rotate tool is right next to where that split tool is that we just used. So now that we clicked on the rotate tool, we have to specify two things. We need to say what lines we're rotating and what point we want to rotate the lines about. So make sure that you have the top box highlighted, not the bottom box. And when you have the top box highlighted, you want to select everything that we use to make that aerofoil shape. So that includes these 3 big lines and this one corner line. And I know this is like really annoying, but I cannot stress, like, it's important not to forget about this one small corner line that you have, because if you do forget about it, the sketch won't be closed and you won't be able to do your lofts correctly. So each time, make sure you're selecting, just keep in mind 4 lines pretty much. You need to be selecting at all times for the aerofoil shape, because those 4 lines are the 4 to create this closed shape. So now that we have those 4 lines selected, we want to click on the center point dialog box. And for this center point, we can just select that point which we just made. And the cursor should turn green when it's right in the center over there. You'll get this pop-up which is saying it's constrained to other geometry. That's just because I think the point has a perpendicular constraint to the line, but you can just select yes for this prompt. We don't really care too much about the constraints here. Half the sketch is unconstrained anyway. And you can see the angle box is highlighted. We just want to type in 25 and then hit enter. And now we should have this kind of shape with the aerofoil on one end being kind of angled 25 degrees downwards, and then on the other end it is straight. And if we zoom all the way out, this is what we should have at this point in the sketch. So hopefully all of your guys' sketches are looking like this. With this, it's basically the same sketch but rotated 25 degrees about this point on both ends. And if I compare it to the final part, you can kind of see how we're getting there. So the 25-degree rotated sketch, if I highlight this, you can see it's on the far end. The straight sketch is on the other end. And the next thing that we want to do is make this middle shape. So where it's kind of bulging outwards, we want to make the sketch that defines that. So in order to do that, we are going to, oh, sorry, I should have said we can exit out of this rotate dialog box. We can finish this sketch. Now we want to go into the center work plane, which was 33 millimeters away from the main plane. So we're going to start another sketch on this plane. Once we started the sketch here, we're going to project a couple of lines down to help us make sure that everything is lined up correctly. And it'll just make our lives a lot easier when we're making this center sketch. So the lines that we're going to project, again, using this project geometry tool, this project geometry tool, it really helps out a lot when you're trying to do this kind of thing with like repeated lofts with similar shapes. So we want to project this whole box from the first sketch that we made and the center line. And then from the second sketch that we made, we want to project this line that's angled downwards. So I'll highlight that again. This bottom line that is angled downwards at 25 degrees is what we're projecting from this sketch. And then this whole box outline with this middle line is what we're projecting from the first sketch. And once we have those lines, we can exit out of the project geometry tool. The next thing that we want to do is we want to make a rectangle, but it is a construction rectangle, again, just like before. So I'm going to click on the construction tool to change the lines that we're making from solid lines to construction lines. And then once again, it is going to, actually, I don't think we use the 3-point center here. We just use a 3-point rectangle. So we don't use 3-point center, we use a 3-point rectangle. And the reason why we use a 3-point is before we were making the rectangle from the center of the shape, but now we want to define the rectangle from one corner to the other corner and then the height. So make sure, yeah, once again, just use 3-point, not 3-point center. So we click on the right-hand side of this angled line that we made. And we kind of follow this line down. And you can see it's at 155 degrees. So if we tab into the 155 degree dialog box, we want to keep that the same. And then for how many millimeters it is, we want to type in 17. And then we hit enter just to define it at 155 at 17, a length of 17 at an angle of 155 degrees over here. And then we want to define the height to be 5 millimeters. I see. Okay, it didn't actually define the angle, but I think that we're fine here. I think it's still following along this curve. So that shouldn't be too big a deal. But now that we have this, we're going to follow a very similar procedure to what we did in this first sketch. So we're going to make a line. Oh, sorry, I'm still in the rectangle tool. Exit out of the rectangle tool. We're going to go to the line tool. And we're just going to go along the top of this rectangle until we get to this green point. And we're going to make a line that is 4.25 millimeters out to the right. 4.25 millimeters out to there. And we should have, once again, these two sketches. So just like last time, the very next thing we're going to do is we are going to make a 3-point arc from the bottom left-hand corner of this rectangle to, oh, sorry, I just realized we're still in the construction. Oh, no, we weren't. Okay, never mind. My bad. Okay, as I was saying, so from the bottom bottom left-hand corner of the rectangle to this 4.25 millimeter long construction line that we just made, we are going to join those 2 points together, and we are going to use an arc radius of 27 millimeters. And I don't know why it keeps switching. It said we weren't in construction line. Now we are again. But anyway, just to exit out of it, even though we just drew a construction line, it's not that big a deal. We can just click on it, click on the construction line again, and it'll become a real line, just like that. So actually, we want to do the same thing with the bottom of the rectangle once again, just like we did last time. And following basically the identical procedure, we want to make another fillet between this. Oh, what the heck? Oh, I think I accidentally had the bottom selected. Just gonna undo that. So a fillet between this arc that we made. So this is the 3-point arc with the 27 millimeter radius. And this side, and sorry, this should not say 1.5 millimeters. That is why I'm not getting a selection. This should say 4 millimeters. And now you can see if I highlight this, it'll give me the little preview. Preview basically indicates that you're good to go whenever you do a tool. And yeah, I don't know why it keeps sending me back to the construction lines. But anyway, I'll keep going. Once again, just close up this gap over here on the right-hand side. We can do this. I think this is what was causing the problem. I think it is okay just to change this line from a construction to a solid line. I think what was interfering before was just this dimension tool, and that's what I was highlighting. I think we should be good if you just highlight this bottom right-hand line and you turn it from a construction line into a real line. But if you don't do that, if you decide to just make a line, you should make, it should be 0.36 millimeters from this corner down to the bottom, and that's so you know that you selected the correct 2 points and you successfully bridged the gap. So, I believe that is it for the center sketch, actually. So now you can kind of see how this is coming together. It's we have these 3 profiles, and we want to make a loft between the 3 that will make this part. And you might think, okay, well, why can't we just do this loft right now as is? So I will show you why. If we select this plane and then we try and loft through these 3 sketches, and then I click, okay. Oh, I forgot. It was not visible. So I'm just going to toggle the visibility for now. You can see we get like this taco like quesadilla shape, which isn't what we were really going for at all with this part. And the reason why is because Inventor just takes the smoothest path between 3 profiles when it does a loft. If we want to actually get like this cool aerofoil type shape, we need to tell Inventor what lines it needs to follow to make the path. And to do that, we're going to make use of something that are called rails. So if you click loft, you can see there's this this selection that's called rails. And I don't think you actually really touch on this at all in first year. But basically what the rails feature does is it allows you to define the path that the loft is going to take. So the rule for rails is that they need to be touching the sketch at all times. Like all 3 profiles of the sketch that you loft along, it needs to be touching all 3 of the sketches at all times, the line for the rail. So how do we achieve that? Well, we have 3 sketches, and I mean, you guys are taking linear algebra now, so I don't know if you learned it yet, but like hopefully you should know. You can make a plane out of any 3 points in like a vector space. So if I go, okay, maybe I'm giving you guys PTSD, but I'll shut up about linear algebra. So you go to the plane tool, and there's a 3 points selection over here. So this is actually what we're going to select, the 3 points tool. And I'm actually going to go back because I think it's good to visualize what we're doing over here. Oh man, I should have unhid these sketches. So maybe I will do that really quick. So sketch 3, sketch 4, and sketch, not this sketch. That is, spoiler alert, guys. That's what we're doing next. But you can see that we are basically defining a line that's going along this edge. And then we're also defining a line that goes along the back. So the point of intersection that we're going to use for the rails is these corner points from each sketch, and then the back points from each sketch. So in order to make sure that our line is always touching the sketch at those points, we can make a new plane that is defined by those 3 points. So in order to do this, we can click on the plane dropdown. Okay, I've done this like 4 times. And then you click on 3 points. And then the 3 points that you choose are the corner points from each of the sketches. So we choose this point over here. We choose this point over here. And we choose this point over here. And Inventor will automatically make a plane with all 3 of those points lying along the plane. And we can do the same thing, basically. We could do it now, or we could do it later. Okay, I'm just reading the handout. It looks like in the handout we do it right now, so I'll do it right now as well. It might look a little messy, but we can clean it up later. So we're gonna use the 3 points tool once again, so the exact same tool. And once again, I'm gonna stress, if you remember, we had this corner line. We had this corner small line that we made. We want to select the very corner of the aerofoil shape, not this line. Like if you zoom out, you can see that there's actually like 2 small points here, and it's very easy to confuse which one you select. So you want to make sure that you're selecting the very corner of each of the 3 shapes. So we're going to select the very corner over there. I'm going to zoom in a ton. Make sure I'm selecting the very corner of this one. And we're going to go over here and I'm going to zoom in a ton again. And I'm going to make sure that I'm selecting the very corner of this one. So now I have 3 lines that are going through the back corner of these 3 planes. So now what I'm going to do is I'm going to go onto the first plane that we made. So the first plane that we made was between these 3 left-hand like pointy parts of the airfoil. And I'm going to make a sketch on this plane. Now, even though we defined the plane to have these 3 points lying on it, these 3 points aren't actually like defined in the plane. Like you can't lock onto those 3 points at all. Like if you make a line, like if I try to like select that point, it won't actually be there on the plane. So in order to have like those points to lock onto, we need to use the project geometry tool once again. And we need to click in a very similar fashion to how we made the actual plane. We need to click on the three tips of the airfoil. So once again, I'm just going to go 1, 2, 3. And then you should have these like 3 little point dots from those 3 tips. So now that we have that, I'm also going to project one more line. And this is just going to make things a little bit easier for us, just to line things up. The same reason why we projected these lines, to kind of help line everything up for how we were making the airfoil. I'm going to project this bottom line from the center sketch. So this is like the same way we projected this line onto this plane, we're going to project this big line onto the bottom plane. And it's going to give us this line at the bottom here, basically this yellow line. And like I realize now there's like kind of a lot going on the screen. So I'm just going to finish this sketch. I'm going to come back to it, but I'm going to hide some of the other sketches just so that it's a little bit easier to see what's going on. So I'm going to hide sketch 4. I'm going to hide sketch 3, and I'm going to hide sketch 2. And this is just to clean it up a bit, just because there's like so much going on in all of these 3. It's a little bit hard to see what we're doing. I'm going to go back into that sketch now. So I'm not going to make a new sketch. I'm going on the model tree and I'm clicking on the sketch that we just made and I'm re-entering it. And this is the sketch we projected all of the points onto. So now that we made this sketch, what I'm going to do is I'm going to make a center point arc actually. So the center point arc is going to be from the line that we just projected. So the very right hand end of the line, or I guess it depends on how you have it oriented, but in my orientation, it's the right hand end of this line. And we're going to go down to the end of that center airfoil, so where the point was projected onto. And then we're going to make a 60-degree arc. And in the handout, actually, this is my bad. I should have maybe specified a little bit more. But it's actually mirrored. So there's a 60-degree arc over here, but this isn't the full arc. So what we're going to do is we're going to use the mirror tool, which is in pattern under circular. And we're going to mirror the 60-degree arc. And we're going to use that center line that we projected as the mirror line. Then we can click apply and we can see that the arc has been projected all the way across. Okay, one sec. This actually looks a little bit This looks like it's going a little bit too far. Maybe it was a 30-degree. This looks more correct, but 1 second. Sorry guys, just give me a second here. I want to make sure I'm doing this correctly. So on the final part, we go into this sketch. Okay, so it is actually 60 degrees from. Okay, it is actually 60 degrees from this line. All right. Oh, sorry. I should just close out of this assembly. Okay, so that is actually 60 degrees. That's my bad. Okay. So once we have that 60-degree arc, we're going to change from, and keep in mind, we use the center point arc tool there. Different tool than what we were using for the rest of this project. We're using the 3-point arc tool. That's why I didn't have to define a third dimension. But now we're going to go back to using the 3-point arc tool. So for the 3-point arc tool, what we're going to do is we're going to click on the left-hand point that we made. So this is for this sketch that is closest to that cylinder. This is not the sketch on the far end of the airfoil. This is the sketch on the close end of the airfoil that is offset by 3 millimeters from the center. And like intuitively, it's the one that's closer to the arc we made. So we're going to click on that point. We're going to click on the point that's joining to the arc, and we're going to make a radius of 35. And it should look like this. And we're going to do a very similar thing between the right hand arc that we made and the point at the very end. And we're going to give this one a radius of 220. I just forgot the dimension there. So we should have something that looks like this. And now what we're going to do is, this shape is like a little bit ugly, so we're just going to smooth it out by using the Fillet Tool. And we're going to give it a 2D fillet, 8 millimeters between this arc and this arc, and then also this arc and this arc. And it's going to unconstrain the left side, but that's fine. Now we have this shape that looks a lot more. Oh my god. Sorry, I don't know if you can hear that fire alarm in my house just started going off. Okay, never mind. It's good now. I guess my roommates figured it out. Hopefully, my house won't burn down. But that should be good, actually, for this part of the sketch. That should be everything that we need. We have this 60 millimeter arc, and we can just finish the sketch off now. So the next thing that we want is we want to do the back side. So this is kind of like a long, skinny plane. Might be hard to select, but this is now what we're going to be working on to make the rail for the backside. So we're going to click this. We're going to click on Create a Sketch. And now that we've done that, what we're actually going to do is we're going to. Oh, sorry. Before we create a sketch, I'm going to retoggle the visibility of all those sketches that we hit earlier. Okay. Okay, awesome. So now these sketches are back. Now that these sketches are back, we're going to make this new sketch on this skinny little plane that we made. Very similar idea to what we did over here. So again, the reason why we made these sketches is because think of like rails as kind of like train track rails. Train track rails need to be touching the train at all times. Otherwise, the train will like derail off and won't go in the direction that you want it to. Same way, think of the sketches as like the train, and then the rails as like the train rails. So like it needs to be touching the sketch at all times. And we can ensure that it's touching the sketch at all times if we make a plane that is touching the sketch at all times, touching all through the sketches at all times. I might have explained that really badly, but sorry about that. So once again, we're going to want to project the geometry. We're going to want to project all 3 corners of all 3 sketches. Again, I want to keep stressing, again, make sure you're projecting the correct point in the corner here, because if at any time you don't project the right point, your loft may not work correctly. So this is also a good time to check that you actually made the plane correctly, because if you did, when you project all three of these points, they should appear on the plane at pretty much the identical location. Not pretty much, they should be at the identical location that you clicked on. If, for example, I click over here, you can see that the yellow point doesn't actually appear where where I'm clicking. It appears like slightly off. Oh my god, what did I just do? Okay. It appears slightly off to the side, and that means that the plane isn't actually lying along that point. So if you click on this bottom point and you find that it's not appearing at the point, it's appearing a little bit off to the side, as this one is here. I'm actually going to delete that, but that means that you probably accidentally made your plane through 3 points using this, using the top of this line instead of the bottom. So you want to redefine that plane. You want to delete it, and you want to remake it by selecting the 3 corners. But okay. Anyway, now that we've done that, this part is pretty simple. So we just want to make a smooth line that's going from this point to this point to this point. And to do that, we're going to use the Spline Tool. And we're going to use the Interpolation Spline Tool, not the Control Vertex Spline Tool. Because the Interpolation Spline Tool, it'll basically make a smooth curve that always goes through the points that we selected. This one is very simple. So we use the Interpolation Spline Tool. All we do is we click from point to point to point. So we click on this point. Then we click on this point. And then finally, we click on this point. Click check. Sorry, actually, I just realized. Okay, everyone's still here. I just wanted to make sure, like, it was kind of quiet. I wanted to make sure my Wi-Fi didn't cut out, and like, I was getting worried actually. So okay, good that we're still live. Okay, awesome. So now we're actually basically almost done this part. So I'm gonna hide a couple work planes, and I'm gonna talk a little bit about what's going on. Okay. I don't know if there's some faster way to like mass hide all of these and selecting them manually, but I'm just gonna select them manually. So these are the sketches that we made, and you can see it's kind of cool. We made like almost a wireframe model of what we're doing. So I'm gonna go back into the loft tool, and when I click the loft tool, and you guys should follow along, you should do this as well. I'm going to loft from the back plane through the center plane and through this. Okay, you have to click to add another sketch, and through this back plane all the way at the end. Make sure when you select these 3, the correct, like make sure you're not selecting the box, you're selecting the inner airfoil shape. You can see now that it's making this taco shape. So basically what Inventor is trying to do over here is it's trying to loft through all 3 of these planes using the smoothest possible line, using the smoothest possible line between these 3 points. So actually, before I go on to do the rails, I'll show you an example actually. That smoothest possible line is exactly what the Spline Tool does. So if I go back into the sketch that we made, these 3 lines along, and I make a spline, a control point spline, between those 3 points touching the curve that we're lofting along, you can see that like this is basically an identical profile to what the loft was doing. Like it's the same Taco Bell shape if I use the Spline Tool and I click from point to point to point. And Inventor basically just does that everywhere. So it makes a smooth spline between the points that are defined on the surface when you just use the loft tool with nothing else defined. But if you want the edges of the loft to follow, oh my gosh, sorry, this is not what you want to do. Click to add, select the sketch, then I select this. Okay, and then we add another selection here. Over here, awesome. We can instead make it follow a different path. And that is what these rails are for. So if I select, for the rails, I'm in the rails menu now. If I select this line, this sketch over here and this line, you can see that now on this end, it's actually following this profile. But you can see the back, it's no longer doing a spline. It's like making this weird wavy shape. And the reason why is because once you define a rail, it kind of tries to like mirror that rail. Like unless you do more and more rails to kind of define how exactly you want your shape to be, it's going to try and like mimic the shape on the opposite side. So that's why we made this backhand rail, because this backhand rail is going to restore kind of that spline shape. And you can see that that's exactly what it does. When I clicked on that backhand rail, we have this nice uniform airfoil shape that's going all the way from one end to the other end of the propeller. So I'm going to click OK here, and it's going to disappear. And the reason why is because I forgot to toggle the visibility back on. So if I turn the visibility back on, you can see that now we have this airfoil shape. And this is basically identical to what we had. Oh, is this the same part? What am I doing? Oh, I'll just finish the sketch. No, it isn't. Okay, never mind. So this is pretty much the same thing that we have over here, but instead, this one has 2 airfoils and this one has 1. So how do we get the second airfoil? It's very simple. You might be thinking we use the mirror tool, but we actually don't. The reason why is because if we use the mirror tool, I'll show you. So if I turn this mirror plane on, if we use the mirror tool, we don't actually get the shape that we want. We get the same thing on the opposite side, but that's not what we're looking for. We're looking for basically this to be rotated 180 degrees. And there's not actually like a rotation tool up here. So instead what we can do is we can kind of cheat by using a circular pattern, which is kind of the same thing. So the circular pattern tool, again, make sure you have, okay, I'll just rehide this plane because we don't really need it. The circular pattern tool is up here in the pattern menu. It's right next to the plane menu. And we select it, and then there are 2 things we need to define. We need to define the feature and the rotation axis. The feature, we can just select as the wing that we just made. So you should just be able to straight up select this big wing. And should have no issues with that. Make sure you don't select the center. Now the rotation axis, instead of a point, remember, we're not in 2 dimensions anymore, we're in 3 dimensions. So instead of a rotation point, we now need a rotation axis. And to get this axis, it's very convenient actually that this is a circle. We can select basically anything on the circle. We can select the inner cylinder, we can select this outer fillet, we can select the body. As long as it's circular, this will give an axis for it to rotate around. So I can show you, like, if I wanted to select the inside, it all has the same effect. Like, it's not changing at all what it's being measured on. And that's because they all have the same axis, the same central axis. But we don't want 6 wings over here. We only want 2. So I'm going to do a placement of 2 with 360 degree currents angle. Like, we could also do like 3 wings too. I guess this actually looks kind of cooler in my opinion with 3 wings. Maybe I should have made the handout with 3 wings, but whatever, too late. Make the placement with 2 wings because that's what we did over there. And we just click OK. And that's pretty much it. That's how we make this shape. You can see it's a much more complicated propeller shape than what we usually make, or than what we made before. And this is kind of an introduction on how to use the more advanced part of the loft tool. And maybe I'll also mention these other ones. So I'm not going to lie to you. I've never used this third one, this area loft, in my life. I don't really know what it does, but seems like we have more time than I anticipated in the workshop. So maybe we can figure it out. But before we do that, I'll talk about what I do know. So instead of rails, which is what we did for this sketch, where we have these kind of outside profiles that we loft along, we can instead use a centerline tool. And basically what you can do with the center line is it kind of shows you, it's nice. It kind of gives you a preview of what exactly is the tool does. Instead of defining like rails along the perimeter that are tangent to each of the sketches, you have to define a line that goes through the center of each of the sketches. So it goes in between, instead of going on the outside, it goes inside of all three of the sketches. And you can loft like between between that line, for example, I guess. So maybe I can show you what that does. Um, I'll see. I don't know if it's gonna work, but I can go back in this propeller design and I can kind of show off how to do like a center loft instead of a rail loft. But they are both kind of the same idea, where instead of it following the outside shape, you want it to follow the inside shape. Like, or not an inside shape. Instead of it following the default spline shape, you can get it to follow a path that you define instead. That's what I meant to say. Sorry. I don't know why, like what I said before is just complete jargon. Um, what else can we do to this? Oh, I have a cool idea actually. I think this isn't really talked about that much actually. There's a tool. Oh, here it is. We can use the bend part tool. Visible unadaptive sketch change. Okay. See if you can do it here. The bend part tool is pretty cool. I'll show you guys what that does. I think. Okay, I'm gonna do this like really ghetto. I'm just gonna make a sketch on this bottom plane, and I'm just gonna make like a line, and you'll see why. This line is just kind of defining the bending point. So, if I use the bend part tool, the bend line, I'll use this. You can see it does exactly what it says. It bends the part, and it's pretty neat. What we can do is I'll bend both sides, and I will bend it the other way. And actually, this could look really neat. Instead of why is it defaulting back to inches? I'll do a 10 millimeter because this circle is 10 millimeter, and maybe I'll do like a 15-degree bend. So it kind of gives like this lifted shape, which some propellers do have that instead of like just a straight line. So if you want to like bend the part as well, this is what you can do. And like it's pretty intuitive what this tool does. Like radius and angle. Basically, the radius is like how far out from the center line you want the angle to bend to be. I don't actually think it'll let you do less than 10 millimeters here. 9. No, it won't. And the reason why, actually, the reason why it's not going to let you do less than 10 millimeters is because this circle is like this center circle that we made. This is 10 millimeters in diameter. So if we tried to bend the part less than that, the circle would kind of like self-intersect with itself, and it would cause like all sorts of weird geometry problems because there would be like a bunch of like self-intersections within the circle if we tried to bend the part. So sure, I'll do a 15-degree bend because that looks kind of cool. Oh, I didn't realize it also bent the center pin, but yeah, I guess it does also bend the center pin when you use that bend part tool. But this is actually a really easy fix. Basically, if we want to like restore the shape of the center pin, we can by the way, like also the main part is done. Like I'm just messing around now. So I just want to show off kind of some other things that you can do in an inventor. Yeah, I will actually we don't need to make a new sketch. What we'll do is we'll take the sketch from the extrusion that we did the first time. You can make this visible again, and then we can just extrude out center part. Sure. No, it wasn't. It was just like I just extruded the donut and not the center part. So I think oh yeah, yeah. Um that would make sense. But like, okay, I think okay, this is extending a little past 9 millimeters. Maybe I'll just make it like 9.2, 3. Yeah, sure, 9.3 millimeters, because that'll cover all that. 9.3, sure, and then okay, visibility still on. Then I'm also going to extrude out the center bit. Same distance, but I'm going to use the cut boolean instead. I'm kind of just like restoring the original shape that this had, but except now we get that cool like bend that we didn't have before. And if now I guess we can, oh, not the tool, sorry, I misclicked. Fillet this 2 millimeters. All right, awesome. So we have this like I basically just reconstructed that centerpiece that got messed up, but now we have this like cool bend which we didn't have before, and it's giving like this airfoil shape. And like this is pretty convenient. I mean, like if you wanted to do a bend, like otherwise, like imagine if you just took a rectangular bar and you bent it, like you would need to um it's convenient to do like retroactively, if that makes sense. Because obviously if you had a rectangular bar, you could just make a sketch on the like the left hand side. So like and like make okay, maybe I'm like talking to myself, sound like a crazy person, but it's really easy to if you have complicated geometry, it's really easy to like do a bend instead of like sweep it along a path. Because like now that we've made this like crazy airfoil, if we wanted to make a bend like that, like it's not really easy to do that, to define with like a bunch of features. And if we didn't bend it, like if we bent it further out, like I bent it right where it intersected with the cylinder basically. But if we use the bend tool and like I made the radius like maybe like 20 instead, and I was bending it like in the middle of this airfoil instead of like right here, that would be like practically impossible. Well, at least with the knowledge that I know. I don't know. Um, Adrian and Val know more than I do, so maybe it is possible, but like it would be very difficult um to make. Yeah, yeah. Oh, I did not know that. I'm an engineering physics student, so I don't take any food. I don't know any of that, but like it's cool that like I was like, ooh, this is kind of a cool shape that I see on actual planes. So, yeah, awesome. Thank you so much. And okay. Okay, let's see what else. Oh, I could show draft as well. Maybe I could draft like the ends also. So kind of what draft does is okay, well it has like the explanation here. But it's kind of like a chamfer, but not exactly. So it'll like take a face. So like I'll do it on the end here because this end is like very straight. And it'll pull the face in a certain direction. So like kind of want to put oh awesome. Okay, you know what I just realized? Oh my god, my inventor. Okay. That tiny little line we made may have been perfect actually for this application. Think about that. Okay. So if I, oh no, okay, that's the pull direction. That's right. If I choose the face, basically I'm taking this face. Oh my God, sorry. And I'm pulling the corner of this face like downwards in this direction. So if you think of it like, basically think like I attached a metal bar to this face, okay, like all the way down, like a wrench. So I took a wrench, I super glued it to the corner of this face, and then the wrench is extending all the way down to where my cursor is right now. I don't know, can you guys see my cursor when I'm showing my screen? Okay, okay. So like where my cursor is, think I have like a wrench attached to the face, sending it all the way down here, and I'm pushing with all my force on that wrench. So what's that gonna do? It's gonna like deform the shape kind of inwards. And you can see like if I change the draft angle, uh okay, maybe because of the geometry of the shape. Usually if Inventor doesn't give a preview, yeah. If Inventor, yeah, okay, create feature failed. If Inventor doesn't give a preview 99% of the time, that means that it's because like it's not gonna work. But oh, I see, I see. Okay. Um, oh, my Inventor's kind of like, okay, I'll try. You know what? I think if I go in the other direction, it might work. So, oh wait, um, what am I doing? I'll do this, like on here. Then maybe I go -5. Wait, face is not selected. I just selected. What is going on? This just worked. Why can I not make the selection now? Okay, I'll give this maybe one more try, and if it doesn't work, give up. Pull direction here, faces, that. Oh, and maybe if I go, I think if I go in the minus direction. Ah, okay, awesome. So the minus direction works, but the plus direction doesn't. I think it was because of this leading edge. So when I'm cutting into the leading edge, it's fine. But if I try and extrude out that leading edge, Inventor doesn't know what to do because it's probably like, my guess is because it's so sharp, it's like kind of twisting the geometry in like, I don't really know how to describe it, but like it'll like the geometry will cross and like the insides will become the outsides. It's kind of weird. Like you don't really, I don't really know how to describe it until you've like seen broken geometry in Inventor before, but like the insides will like cross and become the outsides if like a point gets too small. You can kind of see it if you do a loft and you like loft up with a really high taper angle. But anyway, so back to that wrench analogy with the draft. Basically now instead of pushing the wrench really hard with the negative angle, I'm just pulling the wrench really hard. So this face is getting like pulled backwards kind of. So you can see instead of it being at like 90 degrees, it's like kind of like pulling back into the aerofoil. And if I made it like higher, like you're not 26, I made it like 40. I think the max I would be able to do this is like 90 because it doesn't really make sense to go any further. Yeah, 90 doesn't even work, but 89. Okay. Yeah, that's what I figured, but sure, we'll do like a 40-degree draft. Okay, that looks a little weird. Like maybe you could clean up that corner a little bit, but like there's so many things like intersecting in this corner. Like I doubt that you could just do a fillet because a fillet would be like between two edges, but there are three edges joining here. So I don't know, we can fix it up later. But now you can see like, sorry? Uh let's say corner setback, maybe. I've never used it either. So uh no, I don't know. Yeah, yeah, weird. Maybe like It does seem like that is a real corner. So I don't know. I thought maybe it wasn't recognizing it as a corner because like maybe it wasn't. Maybe there's like, like inventors sometimes it's like infinitely small, but it's not quite a corner. But I don't know. I don't know. Whatever. But yeah. Yeah, so okay, it looks kind of weird now because that's on one side, not the other. Maybe I'll quickly. Actually, I don't know if I can get the draft working correctly on the other side. Maybe I'll be able to do it really fast. So there, faces here, draft angle -40. Wait, is it? Or maybe it would be 40 degrees since it's on the other side. No? Uh, Interesting. But it doesn't seem, huh. That's weird because this is like identical. It literally was defined to be identical to that one. So I don't know why it's not working. Maybe I just defined it wrong. But you should also be able to do a draft on this side. And then like worst case, what I would do, like if I couldn't get it working on the other side, I would like go back in the feature because like we're not that far in the tree. I would like do the draft before I mirrored it, and then it would like automatically apply. Actually, I don't know if you can do it in Inventor, and it might like crash my Inventor, but like you like drag feature. Oh, you can. Uh oh, but I can't drag the face draft before the circular pattern. What if I drag it all the way? That didn't work. Oh, it's because I think the one I did the draft on was the mirrored one. Wow, I had a 50-50 shot and I blew it. Awesome. Okay, I'll move it back. So basically, what I was trying to do there, I'll like explain a little bit more, was I made this draft and I could get it working on one end and I couldn't get it working on the other end, even though it was identical. And like, if I'm being honest, sometimes like that's just Inventor. And like even I was literally making this like when I was making this like propeller for the first time, I tried to make this loft that we made like just this loft like identical. I literally followed the identical procedure. When I got to the end of the loft, it said like loft feature failed. And like usually that happens when you don't define something correctly. But like I knew that I defined everything correctly. So I was like, what the hell is it? I clicked save on my part. After I clicked save on my part, it worked. And it's just like, why? I don't know. Nobody knows. Inventor just like sometimes it just like does like random stuff. So like if you really can't figure something out, I would say like the easiest thing is try saving your part, try turning it off and on again, and then try troubleshooting first. Like try troubleshooting after that. Because like you can spend like hours on something and it'll be like something that wasn't even your fault at all. It's just Inventor being Inventor. And like my guess is this thing would just be Inventor being Inventor. But like if I couldn't get it to work, one fix that I was thinking of doing was I was going to move this feature in the tree to before I did the circular pattern. And by doing that, what would happen is it would mirror this feature onto the other side. Because if you imagine we did this draft before we mirrored it, then we would get the same thing on both sides. But the problem is when I made this draft, I made it on the opposite end. So I didn't this side, if I click the circular pattern, this is the original blade. And the reason why it's showing under is because we did that bend part thing, but this is the original blade and I did the draft on this end. So even though I moved the draft to before the circular pattern, nothing happened because I would have had to done the draft on the original part feature that wasn't rotated 180 degrees in order for that to work. So yeah, that's why like my hack didn't work. I had a 50-50 shot to doing the draft on the right face. I messed it up. But um yeah. What else? What other tools do you think maybe could show off in the 3D workspace?
I have one that I
Okay.
not necessarily 3D workspace, but I think it's really useful, and
Okay.
it should only take 5 minutes. So if you
Okay.
have your part
Awesome.
here, and you go up to the Manage tab up at the top, and click the button that says Create Ipart.
Okay.
Yeah. It's a little hard for me to see.
Uh,
Um,
I oh
it's
okay, I can make
okay.
it bigger.
That's a little
Oh, but it
better.
doesn't
Yeah,
it doesn't help the font. My bad.
that's a little
But,
better. Yeah, that's okay. Um, so basically, what we see here is like we have all the features of our part in the left half of the screen, and we can add one of those dimensions to the right half of the screen. So what I was thinking here is go find the dimension for your bend in here, or your bend feature, wherever it is.
okay,
Yeah, and just yeah, find the
maybe
angle
the
dimension.
angle. Yeah.
Yeah, and then put it over to the right side.
Do I just drag and drop, or do I
You
click
just
this?
click that. Yeah,
Oh,
there you
okay.
go. Yeah. So now on the bottom half of this window, you see how there's like a little table there?
The member part number
Yeah.
table,
Yeah.
E36. Okay.
So if you insert new rows in that table, I think you just like right
Uh,
click, like
okay.
insert
Yeah.
row. Yeah. And you just do that like, let's have like 3 different rows, for example. So just
Ooh,
make one
okay.
more.
Yeah, I kind of see where this is going. This
Yeah.
is new to me too, but oh, why can I not? Oh, there we go.
Yeah. And then you can just like change the degrees, the angle here to whatever else you want your other parts to be. What this is doing is you can create multiple instances of this part using this table here. And the multiple instances of the part will be all slightly different depending on the dimensions that you change in the table. So this is really, really good if you're, say, manufacturing and designing a bunch of screws, for example, because screws come in lots of different lengths and diameters, pitches, and everything, right? So you could just have a table full of your dimensions for your screws here. So you could have like your 10 millimeter diameter screws that are 20 millimeters long. You can have ones that are 40 millimeters long. Then you can have ones that are diameter of 6 millimeters and they're 60 millimeters long. That's kind of a weird aspect ratio for a screw. But you could just all do that in this table here. And then afterwards, you just click OK. So
Okay.
if you've already edited those angles in there, then you just click OK. And you see in your model tree, it created a new item right up at the top there. It's called table 2 or table 1.
Oh yeah, table. Yeah, I see
Yeah,
that.
and then if you just like double click on one of these other ones,
Ah,
yeah, and it actually, and if you right
yeah.
click that in your model tree, if you right click one,
Uh,
yeah, and then you
mhm.
just hit generate files, yeah, then it just
Okay.
asks
Oh,
you to
I
save.
actually haven't
Oh,
saved this part. I haven't even saved this part since I like
dangerous,
started the workshop.
dangerous,
Propeller one.
yeah. So now that you've saved it, what generate files does is it creates like their own IPT files for those other parts you made. So
That's pretty
this,
neat. And
yeah, yeah.
just a question about that feature. So if I were to keep making edits to the original part down the line, will those be applied to the table features or no? Like would it keep updating as I
Uh,
was editing the
I think so. Yeah, I
Well,
think
I
you'd
mean, I
have
guess
to.
that's something we could test like right now.
Yeah,
Oh,
yeah.
oops.
I'm
Didn't
not
mean to do
entirely
that.
sure, but I think it would, as long as you don't change. You might have to go back and do the create I part again, but I don't think you'd have to make any edits to your table or anything. I haven't tried it.
Oh, it does.
Oh,
That's neat. So you could like do that at any time, and like as long as I guess it's the edits you make are compatible with the
mm-hmm.
different angles, it'll keep updating the part as you make changes. This looks like a this is starting to look like a Lego head now. It looks like a kind of like an angel Lego head with like wings on the sides. We just like add like the thing up top here.
Oh
I think
yeah.
actually I don't know if Dr. McDonald's done it yet for first years, but like one of the bonuses was a like design a Lego feature, a little mini Lego guy, and like he would feature the best ones. Like you would have like a vote for what the best ones were. So I don't know, like if you guys want to take inspiration from this, like instead of not on the head, but like if you're making your Lego part, you can give it wings like on the back. You can follow like a very similar process to what we did here. And instead of like making kind of a helicopter type shape, what you could instead do is you could make a like wing type shape. And something you could do for that is like you you could like possibly use like maybe I'll do I usually do this in Fusion, so I'm not sure how it works in Inventor, but like the canvas tool is like if I make a sketch or to make a sketch here. Oh, is it image? Okay, I don't know. I don't have an image ready on the fly, but like basically what you can do is you could put a picture um on like the body you were trying to make. So like for example, if it was like your Lego head, and then you could like spline out like you could use that control point spline that I used, and you could use that spline to basically like trace the shape of the wings. And then you could extrude out those wings and then you could bend them to make them look neat like this. And that would be like something that's like pretty neat. I don't know. Maybe I'll see if I can like speed run that on a new part in like 7 minutes. I don't know. Unless Adrian, you have anything else you would like to share for this part too. Yeah. Okay. Okay, awesome. Oh yeah, I guess